All right, so we are given this problem, binary subarray with sum, right? So we are given a binary array and an integer target, right? Another variable which is called target. And we need to return the number of non-empty subarrays with a sum which is equal to the target from this particular array, right? So for example, over here, this is our input array and this is our target, right? Target is 3 over here. We need to find all the subarrays within this particular array whose sum is equal to 3, right? So this is the equation pretty much. And yeah, I mean, if you see this sample input, you only have two such subarrays over here. One is 1101, whose sum is equal to 3, and another one is 1011, right? Whose sum is equal to 3 again. And that's why my output is 2, which is nothing but the count of such valid subarrays. And so that's going to be my output. That's what I need to return, right? So maybe you can now pause this video and try to think of a solution. And once you are done, you can come back and have a look. So now, if again, like if you thought about the solution for this particular problem, you would have realized that it's not again very easy to find, subarrays with exactly uh, sum equal to a given target, right? So uh, that's something which is a little bit trickier to find. But what can be done is that we can find all the subarrays within this particular array whose sum is less than or equal to target, right? And what we can then do is once we find all the subarrays whose sum is less than equal to target, we will again find all the subarrays whose sum is less than equal to target minus 1, right? So now what will happen is, for example, let me just write it over here. Let's say the function that we have written to find all the subarrays with sum uh, less than equal to target is f. So if I run it for target, I will get all the subarrays whose sum is either equal to 3, right, equal to target, or the sum is, uh, anything less than 3, right? Similarly, if I run this particular function now for f of target minus 1, right, now what will happen is that now, I will get all the subarrays whose sum is less than equal to, whose sum is less than equal to 2, right? It can be exactly 2 or it can be anything less than 2, right? Now if I subtract this result from this result, I will be only left with those subarrays whose sum is exactly equal to target, right? Because whatever is less than target, I have already included in this target minus 1, and that's what I'm subtracting from this particular result. So I will be left with only those sum arrays whose sum is exactly equal to the target, right? So that's the intuition behind solving this particular problem. Now, to calculate the count of the subarrays, with sum less than or equal to target, what we can do is we can make use of the two-pointer approach over here, and we can use a sliding window technique. So we can have, two pointers, start and the end pointer initialized to the 0th index to start with. And what we can do is we can, keep checking at every step. So we will just keep incrementing our end pointer and keep expanding the window. And at every step, once we are like incrementing the end pointer, at every new step, at every new element, we will check if my current sum is less than or equal to target or not. If it is equal to less than or target, I will further increment my end pointer, and I will further expand my window. So I will keep expanding my window. I will keep moving my end pointer towards the right, one element by uh, at a time, till the point I hit an element which makes my sum greater than the given target, right? For example, right now the target is 3. Let's say if I come over here, I mean, this particular element would make my sum equal to 4, which is greater than target, right? That's where I will stop. And now I will start shrinking my entire window, right? And now I will start removing one element from the beginning, right? And I will keep incrementing my start pointer now, right? I will keep excluding one element from the beginning of the array, and I will start shrinking my, uh, you know, window size till the point again I get some less than or equal to target, right? The moment at any element I get some less than or equal to target, I will stop there, and then I will again start, incrementing my end pointers if at all there are further elements, after the current end index, right? So I will keep repeating this process, and I will just do it for the entire array. And what I will also do is, now one important thing, right? We need to find the count of the subarrays with sum less than or equal to target, right? That's what our motive is. So what we will do is, at every step, we will keep incrementing the count variable, right? That we are maintaining to actually track the, uh, the total sub array count, which, meet this particular condition. Their sum is less than or equal to target, right? So at every step, anyways, we are going to check if my current sum is less than or equal to target or not. If it is less than or equal to target, first I'm going to increase my count of the sub arrays that I've found so far, and then I will increment my end pointer, right? That's what I'm going to do at every step, right, as I'm moving forward, right? And let me just write it over here so that you're clear. So I will do, at every step, I will keep incrementing my subarray count by this particular formula, which will be end minus start plus 1. Now, if you're wondering why this, why this particular formula, this will actually give me the total number of elements which are present in my current window, right? That's what it is doing, right? End minus the starting pointer of the window plus 1. That will give me all the elements, the count of the elements which are present in my current window, right? And why would that be correct? Because now just try to understand this. Let me use a laser pointer over here. Yeah. So now, for example, currently I'm here, right? For example, I'm here, right? I've already scanned till this particular point, and I already have, whatever is the count till this particular point. Now what I'm doing is I'm moving my end pointer to this particular element, that is 0, right? Now once I move over here, now the first thing I will do is I will again check, I will increment my sum, I will add this particular element to my sum, and then I will again check if my sum is still less than or equal to target or not, right? And it will be less than or equal to target over here since my target is 3. So then what I will do now is, now, what does this mean, right? This means that this particular entire sub array has sum less than or equal to target, right? Which means every other sub array, inside of this particular window will also have some less than or equal to target for sure, because this entire array, since it has some less than or equal to target, definitely every other sub array of this particular window will also have some less than or equal to target, right? So now, by the addition of this particular new element in my window, I will also have to add all those sub arrays which got newly added by adding this particular element in my window, right? And how will I calculate that would be, this particular element can actually be combined with every other element in this particular window, right? It can be combined with this particular element to form a particular subarray. It can be combined with this particular element to form a subarray. It can be combined with itself, right, to form a single digit subarray as well, right? So essentially the total number of new subarrays that will get added because of adding this particular element in my window would actually be the count of the total elements present in my current window, right? Which will be given by this particular formula. And that's why at every step, when I'm checking if my sum is less than or equal to target or not after adding that particular number, if it is less than or equal to target, then I will be incrementing my count of the subarrays by this particular formula, end minus start pointer plus 1, right? And so like at the end of the entire array, once I've scanned everything, I will, get the total count of the subarrays which have sum less than or equal to target, right? Right. And then finally, what I'll do is I will also do the same thing for target minus 1. For example, if target is 3, I will then run this entire process for target equal to 2, and then I will find the count of the subarrays whose sum is less than or equal to 2, right? And then I will subtract this particular, like the uh, subarrays with less than or equal to 2 sum from this particular sub count, where all the subarrays, count of the subarrays where the sum is less than or equal to 3, and that would give me count of all the subarrays where the sum is exactly equal to 3, right? So that's the entire intuition behind this particular problem. I hope you got it. Now let's code this particular solution, and that will give you a better understanding of the intuition behind this. All right, so Let's implement the solution that we just discussed. So let me create a function over here and let me create the at most sum function first, which will get the count of the subarrays with less than or equal to target as the sum. It will expect two parameters as input, target, and then what I can do is I can take the length of the input array as n. I can initialize the CNT variable, which will track the count of the subarrays that we have encountered so far. That was 0 to start with. The current sum variable can be initialized to 0 again, and then I can have a start pointer again initialized to 0, right? And now for the end pointer, what I can do is I can either create another end pointer over here and use a while loop while n is less than equal to n, or what I can do is I can simply use a for loop like this for I in range n, and then use this I variable as the end pointer, right? So it will mean one or the same thing, right? Now over here inside of this for loop, what I will do is I will keep incrementing my sum with the current element first of all, right? And now I have to check whether my current sum is uh, less than or equal to target or not, right? Or if it is greater than equal to target or not. Because if it is greater than equal to target, then I have to start shrinking my window, right? So that's something that maybe I can check first, right? I can say while my sum is greater than target, right? So if it is less than equal to target, of course, this while loop, internal while loop won't run. But if it is greater than target, then I'm saying that you run this while loop, and then what we need to do is we need to keep removing one element from the beginning. So I will say sum minus equal to array of my current starting pointer, right? And then I can increment my starting pointer by 1, right? So I will keep doing this till this particular condition is met. The moment I reach a point where again my sum is less than equal to target, I will come out of this while loop. And then what I need to do is I need to find the count of, I have to update the count, with the new additional subarrays that we have found. And that will be nothing but, as we saw, it will be end pointer, which is my I over here, minus the starting pointer plus 1, right? So, if, for example, at any point in time, my sum is not greater than target, it is less than equal to target. So it will not run this particular while loop. It will directly come over here and it will increment the count variable, right, by this particular formula, and then it will go to the next iteration, right? So, I mean, don't get confused over here because I haven't written the condition of if sum is less than equal to target. But I mean, that is implied over here, right? If this is not met, then that will be automatically met, right? And it will hold true. And so I have to either ways like increase my total count by this particular formula, right? So if my sum is greater than target, for example, at any point in time, I will keep shrinking my window. And then once I get my sum less than equal to target, I will come out of this while loop. And then again, I will be needed to actually, increase my count variable by that particular, this particular formula again, right? Because I found a new sub array basically, found a new array, new element, right? So that's the reason I'm doing it this way. And then finally, I can return my count variable, right? And that's it. And then what I can do is I can create another function which will call this particular function. I can name it as number of subarrays, right? It will also expect array and target as input. And what I need to return is I just need to return at most sum of array and target minus at most sum of array comma target minus 1, right? And this will be my final output, right? And maybe what I can do is I can just try to test this now by running a print statement and calling this particular function number of subarrays. And I can use the same example that we saw earlier. It was 1 comma 1 comma 0 comma 1 comma 1, and target was 3, right? And this should give me 2. The output of this particular test case should be 2. Let me run this now and see what happens. Yeah, so I got 2 over here, which is correct, right? So this is entirely the solution of this particular problem. And also, like, just to talk about the space and the time complexity, so we are not using any extra space over here. So like the space complexity will be order of 1. And since we are scanning the the entire array at most twice, right? If we just keep increasing our end pointer and then we also shrink our the entire window by incrementing the start pointer. In the worst case, at max, we will be just scanning the entire window only twice, right? Which will be nothing but order of n time, right? So the time complexity is order of n over here, and the space complexity is order of 1, right? So I think this is it. I hope you understood the entire implementation, and I will see you in the next video. Thank you.